so good to see you.
You too.
How are things?
Lovely. We've got some sunshine here right now, which is always nice.
Yeah, it's sunny and maybe a bit too sunshiny here today. But so, what I wanted to talk to you about today is a tool called Elastic, and more in general, the idea of pixel classification. What that is, why it might be helpful. Because Elastic is one of our favorite tools, and we end up using it a lot, especially for projects that are a little bit trickier. So I wanted to sort of let everybody know that this resource exists.
Awesome. I love new tools.
All right, let me go ahead and share my screen.
And I think something, worth double pointing out that despite, as image analysts, despite being the team who maintains CellProfiler, right? I mean, like we use lots of different tools, and
Yep.
any image analyst, you may have your favorite tool. I mean, I think we've shown in lots of episodes that we often, the very first thing we do is look at images in FIJI, even
Mhm.
before moving into a CellProfiler pipeline. And just something to point out that you may be an expert in a given tool. But that doesn't mean it's the best. And there's lots of awesome tools out there. And Elastic is one that we love and use all the time in our lab as well.
Yeah. CellProfiler might even be our favorite, multi-tool, but sometimes you need just a really darn good screwdriver. Sometimes you need another tool that's better at what you need to do than this thing that is your go-to standard. So, and we love Elastic for things where doing segmentation can get a little bit complicated.
Absolutely.
Um, so here's one example. So these are some cells that were taken with phase contrast imaging, where we're using just white light. We're not doing any fluorescence. Um, and by eye, I can really confidently say, this is the boundary of this cell. This is the boundary of this cell. Because our brains evolved over millions and billions of years to do that. Um, a program like CellProfiler that's used to dealing with fluorescence images is going to get really confused because it's going to say like, hey, you told me to look for bright things on dark backgrounds, and that's not this. We may, in a future episode, talk more about what are the ways that you could make an image look more like this. But one of the tools that makes it really easy to make these cells look bright on a dark background is Elastic and this idea of pixel classification.
Ooh.
Um, So there's a lot of different things you can do with Elastic. I'm just gonna be like skimming the surface here. Um, but this is a set of things that we generally find really helpful. Um, oh no. I think I can just drag and drop rather than having to spend 5 minutes sort of exploring my whole archive. I can. Thank you, Elastic. So I've brought in a bunch of these different images. And Elastic is going to ask us to pick some features. This isn't going to mean anything, or it's going to mean more once I actually start working with Elastic. So I'm going to go ahead and just select these and then come back to telling you what they are and why.
I'm going to hold you to that.
Okay, you do, please.
Okay.
All right. So here I'm given this idea of two labels. Two labels doesn't mean that much to me. Let's say I would rather call these background and cells. Because there's two kinds of things in this image. There's background and there's cells. Depending on how pedantic you want to be, there are more kinds. There's, little bits of, shadow and things like that. But there's two major kinds of things that I want to know. I want to know, is this part of the background or part of the cell? And so the way I'm going to teach Elastic to do that is I'm going to drop my brush size down to one. And in a future episode, we'll explain why it's important to drop your brush size down to one. But it's really important to drop your brush size down to one. Just take my word for
Yeah, just trust us.
it.
It's not usually that we say like this is a rule and follow this rule and it does, like we'll explain why later, right? Or not explain why, but this is a rule. Like very rarely do we have moratorium or Mandates. There we go. Very rarely do we have mandates without sufficient explanation because we love teaching and training. But this is a mandate. Just trust us. Or
Future episode.
keep an eye out for the next, for a future episode where we explain why.
Yeah. Um, so I'm gonna ask Elastic, what is the difference between background and cells? And so I have to teach it what is the difference between background and cells. And so the way I'm gonna do that is I'm gonna annotate, and I'm gonna start literally by just annotating one pixel in each cell. And I'm now gonna hit this magic live update button, and magic's gonna happen. You ready? Ready for magic?
I don't know.
Let's do it.
Let's do it. What?
Magic! So Elastic has turned all of the pixels of the background yellow, and all of the things that it thinks are cells, it's turned blue. I'm gonna add just a second one. I'm
Okay,
gonna,
but wait, hold the phone, Beth. That was with literally 2 pixels.
yeah, yep, it was.
Literally 2 pixels. It already,
Yeah, and if I turn on my segmentation, it's pretty good. So
wow.
what actually happened? How does the magic work? So if I turn off live update and go back to this feature selection mode, now I told you I would explain.
Okay.
What Elastic said is, okay, you gave me two and then later a third pixel. For each one of the things that you told me to measure, so little circles around that pixel, very small pixels, zero point 0.3 pixel diameter, including big pixels, 10 pixel circle diameter, measure things about the color of the pixels in that area. Measure things about the edges that are around that pixel. Measure things that are about the texture of that part of the image. And then make a classifier. So this is why we call it pixel classification. So if it says, hey, the texture here is really different than the texture in the background, which by my eye, I'm pretty sure is true, then it will use something like the texture to say, I can classify if this pixel and this pixel versus this pixel have different properties, and I can learn to split those things apart. And in fact, it will actually suggest what are the most important features, and I bet they're going to come up as texture features, but we can kind of see. So it's going to ask what the features it should use are, and I'm just going to hit run feature selection and see what happens. Live demo, so who knows, but um, so actually it's about different smoothing things. So there you go. It wasn't exactly what I predicted, but how the image changes when you smooth it.
Interesting.
Um, yeah.
Which I imagine has some relationship to texture,
Hmm.
but
Yeah.
a different way of
Hmm.
mathematically approaching that.
Hmm. Yeah. I also have only given it a very small number of pixels to learn from. Possibly if I gave it more pixels, I'm gonna, for example, it said that this was, it thought was a cell. Um, Change that and put a background label there. And now see if, oh, I have to turn on live update for magic to happen. Magic happened. And so there's a couple little holes in here. I could spend more time, but with just a couple of pixels, literally four, if I zoom out, you can see I've done a pretty good job on this image. And if I switch to some of the other images in my data set,
Oh my gosh.
those are looking pretty good too.
4 pixels, completely
Mhm.
different images. Like
Yeah.
that's nuts.
Mhm. Um, I want to show you actually even a more fun example both of these image sets are actually things that I found um, in the Bird Bioimage Benchmark Collection, or the BBBC. Um, so I'm going to go ahead and restart Elastic. So here we can see why CellProfiler might not do a good job because it wants things to be bright and the background dark, and that's not what we have here. Here our background is dark, but what we have here are actually, these are synthetically made cells, but they're cells of lots of different shapes and colors. So
Hmm.
the nuclei are always blue, but the authors here computationally made a bunch of cells with lots of different colors so that they could test how well classification algorithms worked to classify a cell as red, green, or blue. Um, so I thought that was a cool data set. And you can imagine that, especially if I care about the difference between the nucleus and these cytoplasms, that it might not be super easy to tell CellProfiler maybe the difference between what parts of the image are cell and which parts are background, but maybe not the boundaries of individual cells because there are lots of different colors. So again, I'm going to make a pixel classification project. And as always, we will put the links to our data sets in the show notes because we love to share good data. All right. So again, I'm going to turn on my feature selection. And so last time I had 2 classes. Now I'm going to have 3 classes. I'm still going to call this background. I'm going to actually change the color also, just because I kind of actually don't want to see the background display very much. We're going to call this nuclei. We're going to call this cell. All right. So we still have our super small brush. Gonna do a pixel of background. Let me zoom in a little. Let's do a pixel of nuclei and let's do a pixel of cell. And then let's watch the magic happen.
Do, 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 do. Ah. Show us the magic.
All right. What did we get?
Hmm.
So it definitely knows background. Um, and for some of the cells, it knows cells. And for some of the cells, it's really not sure. If I turn on Elastic's uncertainty view,
Oh,
it's kind of, so here uncertainty is marked as teal. It is pretty certain, or more certain anyway, in the cell that we marked as part of a cell. It's really uncertain in the green cell because we haven't actually annotated it with anything green.
yeah.
And this is where our discussion about overfitting and stuff comes in, which we're going to talk mostly about in another episode. But let's see if I can get something to work. So I'm going to break my rule. I'm going to try to make my cell here. I'm going to turn on the big brush and I'm going to give it lots of cell pixels that are red. What happens to our segmentation guess now? It actually did pretty well. And I'm pretty sure the reason that it did pretty well is because we have texture features here that are similar
Hmm.
between red and green. Um, I suspect that if we set this to only use intensity features and not some of the texture or smoothing features, we actually wouldn't get such a good result.
So
Um,
what you're saying is it's probably actually just ignoring the color now that
mhm.
you've added so
Yeah,
many of those other pixels and
yeah,
focusing on what
hmm
is similar
hmm
between the
yeah,
objects.
which we can check. Uh, yeah, so these are now definitely getting into some very textury features. It's kind of ignoring the colors.
Hmm.
Um, if it had had a hard time learning this green, the more that I sort of annotated red, the more green I would have had to add in order to get it to go well. Um, One way I still might be able to show you that is the nuclei I haven't annotated very much yet. If I put, and it's not doing a very good job because it's now seen so many cell pixels, it thinks most things are cells. See if I drop just a couple more nuclei pixels. So now I maybe have like 5 nuclei pixels. What do I get? All right, it didn't take very many this time, and that's probably because this is a pretty easy task and the nuclei are a different texture. Um, So I wasn't able to get it to overfit this time because Elastic just has so many useful features that it does such a good job that I'm not actually able to demonstrate overfitting. But we will have another episode where we talk about the importance of being able to actually say um, that the number of annotations that you make in each kind of phenotype that you're looking at actually matter. But I
That's
think
one
where
thing.
we can, yeah.
Oh, sorry. I just one thing I'm noticing is with this latest
Mhm.
prediction, it looks like it's predicting nuclei in the middle and then cells around it, but then sort of a layer of nuclei again.
Yeah, I noticed that too. I suspect why is because it thinks that nuclei are things surrounded by cells. So if we and so if we put a bunch of annotations in the background just far from the cell, I'm not sure if that'll fix it. We can figure that out. So that didn't do much to fix it.
Mm-mm.
But I suspect if we put some
Oh,
examples right there, sort of close to the cell,
and that was just one more pixel. Like
yeah.
one pixel in the right place
Hmm.
made that huge difference when a whole bunch of pixels in a place it was already doing well didn't
Hmm.
actually change anything appreciably.
Yeah. And that's a really great point. So let me demonstrate that now even a little more, which is let me erase all those pixels. Let me turn on the uncertainty view. Right now, the places that I put those pixels initially are pretty already darn certain.
Yeah.
So it doesn't matter if I sort of draw out here all day. The things aren't going to change much because, I've now made this uncertainty even less, but I haven't actually fixed my segmentation problem at all. But if I go to where the uncertainty is high, then I can fix my segmentation much more easily
Yeah.
with many fewer pixels. And fewer pixels is always better, as we'll talk about in a future episode.
Lovely.
But yeah, Elastic is really great. You can see it's robust to all kinds of shenanigans that we can try to throw at it, even when we're trying to throw at things. But it's a great way to make your image into sort of the thing I care about is found specifically, even if the thing is all the same color or as many different colors, both of which CellProfiler struggles with. And so there are many use cases for using Elastic. Definitely check out their website. We'll put it in the show notes, but those are some of our favorites.
Absolutely. I think one thing too, and maybe this is for a future episode, is that often we are using multiple tools in a single analysis task. So here, Elastic has done a brilliant job of getting these objects for us. And then we may take these objects and bring them into a cell profiler pipeline and make the measurements that we're interested in a cell profiler pipeline, bringing in these objects. And then even within the cell profiler pipeline, you can do the things that you're familiar with, perhaps familiar with already in cell profiler about, around object identification. We could fill the holes there or smooth it out, um,
Mhm.
or, add or subtract a bit of,
Yeah.
some number of pixels to the edge of the objects. So
Mhm.
lots of
Yeah.
extra things
And the
that,
holes are definitely there more in the green than they are in any other color because it
yeah,
knows the least about green.
yeah,
So we moved a little bit. And here we would have a lot of uncertainty just because it never saw a blue cell. So the red cells definitely perform much better than the green and blue ones.
yeah, absolutely. So that'd be something you could either
Mhm.
continue to improve
Mhm.
your pixel classification here in this pipeline, or if this was the best you had, bring it into another tool like CellProfiler
Mhm.
to I mean, already one more pixel and it's so much
Mhm.
better. But you can bring those into CellProfiler to then do further work with.
Mhm. Couldn't have summed it up better myself.
Sorry if I took the words.
No, no, it was
You were going
perfect.
there and I jumped ahead. I just got excited.
Good image analysis is always exciting.
Of course.
All right. So good to see you. See you
You
next
too.
time.
All right, sounds good. Bye.